Hi guys, this is A2 Chemistry, Organic Chemistry, and we are doing organic synthesis. Question 18. Compound G can be synthesized from benzene by the route shown below. So, benzene, when it reacts with HNO3 and sulfuric acid at 55 degrees Celsius, results in the formation of nitrobenzene. And the position of the nitro group is determined by the position of the NH2 group in the product of step 2. So, NO2 on reduction produces phenylamine. Phenylamine would produce a molecule that contains two nitrogen and a chlorine atom, which means that it is converted into benzene diazonium chloride. So that would be N triple bond N positive and Cl negative attached to the benzene molecule. And this, upon hydrolysis, would produce phenol, and phenol, upon esterification, would produce the ester, which is G. But this esterification is basically acylation because phenols do not react with carboxylic acid. Phenol would react with the acyl chloride. So the acyl chloride that phenol would react with would be CH3COCl. Name the functional group formed in step 5. It is an ester group. Draw the structures of intermediates H and J in the boxes above. Already done. Suggest reagent conditions for the following. Step 2. Step 2 is reduction. So reduction of a nitro compound is on reaction with tin and concentrated HCl. So that would produce phenylamine. Next, step 3. Step 3 is formation of benzene diazonium chloride, which requires HNO2 in the presence of NaNO2 and HCl, and temperature less than 10 degrees Celsius in order to form benzene diazonium chloride. Next is the conversion of benzene diazonium chloride into phenol, which would require water and heat. H2O plus heat is required to convert benzene diazonium chloride into phenol. Step 5 is acylation. So this would require CH3COCl to react with phenol to form the phenyl ester, which is compound G. Question 19. The following chart shows some reactions of ethyl benzene and compounds produced from it. So ethyl benzene can form a compound that has chlorine on its substituted group, R group, which is through free radical substitution, or it could form a compound with bromine attached to the fourth position relative to the alkyl group, which can be converted into benzoic acid upon oxidation. Ethyl benzene, when it forms a chlorine containing compound, can be converted into uh, benzene ring with a double bonded R group attached to it. This would be by removal of chlorine from one carbon and hydrogen from the other. Dehydrohalogenation. Ethyl benzene itself can form nitrobenzene through electrophilic substitution, which can form amine group through reduction, which can form benzene diazonium chloride when it is kept at a temperature below 10 degrees Celsius along with HNO2, NaNO2 and HCl. And upon reaction with sodium phenoxide, it forms compound X. And the question asks, draw the structure of compound X in the box provided in the chart above. So this is basically an azo dye in which we have the benzene ring that contains the CH2 CH3 group with the diazonium chloride. So N triple bond N becomes N double bond N. Cl goes away. and this end of the molecule is bonded to the fourth position relative to the O minus Na plus. So when Cl exits the N2Cl group, Na will exit and will be replaced by hydrogen. So this becomes OH. And this is the azo dye that is formed, which is represented by X. Suggest reagents and conditions for each of the reactions, writing them in the spaces below. So reaction 1 would require chlorine, gas and UV light. Reaction 2 is electrophilic substitution and bromine is present, so that would require bromine and AlBr3 to bring about bromination of benzene. Next, the third reaction is removal of H and Cl. So this is the reaction with NaOH in the presence of ethanol and heat. So this would remove a hydrogen and a chlorine atom and it would result in the formation of a double bond between the two carbon atoms. Reaction 4 is conversion of ethyl benzene into ethyl benzene with a nitro group on it. So nitration of benzene is taking place. So here we would have HNO2 plus H2SO4 and temperature between 50 to 55 degrees Celsius. And it is also possible that because it is an alkyl benzene, a temperature between 30 to 50 degrees Celsius is also sufficient, which is called warming of the reagents. We can use the term warm here as well. So, next reaction is reaction 5, in which the ethyl benzene is converted into benzoic acid. This is brought about by oxidation. So, oxidation needs acidified KMnO4 and heating, which would oxidize the ethyl group and convert it into the COOH group. Next, we have reaction 6, in which the nitro group is converted into the amine group. So, nitro group converting into an amine group requires tin plus concentrated HCl to bring about this reaction. And finally, reaction 7 is the conversion of the amine group into benzene diazonium chloride, which is brought about by reaction with HNO2 in the presence of NaNO2 and HCl and temperature less than 10 degrees Celsius. Question 20. The following scheme outlines the production of some compounds from ethene. So in step 1, ethene is converted into 1,2-dibromoethane. A. On the left, excess of ammonia, heat, heat in ethanol under pressure would convert this into diamine, in which we will have H2N, CH2, CH2, and NH2 present. This is nucleophilic substitution. On the right, the same dibromoethane is reacted with KCN and heated in ethanol, which would bring about nucleophilic substitution again, but this time instead of NH2, CN would be added to the ethene molecule on which two bromine atoms were present. So it will form a dinitrile, which is converted into a dioic acid by acid hydrolysis of the nitrile, which upon reaction with SOCl2 will be converted into an acyl chloride. So COCl on the left and COCl on the right. And the dinitrile can also be converted into a diamine by reduction. So this completes the organic synthesis pathway that has been given. Suggest the reagent and conditions for reaction 1. So reaction 1 can be brought about by reacting ethane with Br2 gas. Describe the mechanism of reaction 1 by means of a diagram. Include all whole, partial, and induced charges and represent the movement of electron pairs by curly arrows. So we have a molecule of ethene and a molecule of bromine. Now, the molecule of bromine has a partial positive and a partial negative charge because of the delocalized electron cloud around the double bond, which is attracted towards the positive charge of bromine. This results in the Br-Br bond breaking heterolytically, which results in the formation of a carbocation on which we have one bromine added onto it and a positive charge on the other carbon atom, and we have the production of a nucleophile, which is also a bromide ion. Now, the lone pair of electrons on the bromide ion are attracted towards the positive charge on the carbocation, resulting in the formation of the final product, which is 1,2-dibromoethane. And this is the mechanism of electrophilic addition with which 1,2-dibromoethane forms from the reaction between ethene and bromine. Suggest the identities of compounds B, C, and E and draw their structure in the boxes opposite. Already done. Suggest reagents and conditions for reaction 2. Reaction 2 is the conversion of the dinitrile into the dioic acid. So this requires acid plus water plus heat under reflux, and also reagents and conditions for reaction 3, which is the conversion of the dinitrile into the diamine. So this is brought about by reduction of the nitrile, which requires LiAlH4 along with dry ether. During reaction 2, the nitrogen atoms are lost from the organic molecule, such as the identity of the nitrogen containing ion produced during this reaction. So the nitrogen ions are lost in the form of ammonia, but since HCl is present, the HCl reacts with the ammonia that is given off and is converted into ammonium chloride. So the nitrogen containing ion present in ammonium chloride is the NH4 positive ion. Question 21. There are several ways of introducing chlorine atoms into organic molecules. State the reagents and conditions necessary to carry out the following transformations. So we have C2H4 converting into C2H5Cl. So this is electrophilic addition because we have an addition of a hydrogen and a chlorine atom. So this is reaction of ethene with HCl. That is the only reagent required. No conditions required here. The next reaction has C2H5OH, ethanol converting into C2H5Cl. So here we have a reaction in which an alcohol is converted into a chloroalkane. This requires either reaction with HCl or reaction with PCl3 and warming, or reaction with PCl5 or reaction with SOCl2, which would convert the alcohol into the halogenoalkane or chloroalkane in this case. So there are four possible ways of bringing about this conversion. Next, we have C2H6, ethane being converted into C2H5Cl. This is free radical substitution, and this can be brought about by the reaction of chlorine gas in the presence of UV light. Next, we have C2H4 converting into C2H4Cl2. This is the reaction of ethene with chlorine gas and nothing else. The chlorine gas will undergo electrophilic addition and will add onto the double bonded carbon atoms of ethene, converting them into single bonded carbon atoms, and both carbon atoms will form a single bond with one chlorine atom. So 1,2-dichloroethane will form. Next, we have CH3COOH, which is ethanoic acid converting into CH3COCl. Now, this is conversion of a carboxylic acid into an acyl chloride. This requires PCl3 plus warming, or it requires the reaction with PCl5, or it requires the reaction with SOCl2. Either of these three reactions will bring about the conversion of a carboxylic acid to an acyl chloride. Next, we have methyl benzene undergoing electrophilic substitution to form chloro-4-methylbenzene. So, a chlorine atom is substituted onto the benzene molecule. So, this requires reaction with Cl2 in the presence of the catalyst AlCl3. And the last reaction is methylbenzene forming chloromethylbenzene, in which the chlorine group is substituted onto the methyl group and not onto the benzene ring. So this requires reaction with Cl2, but this time in place of the catalyst AlCl3, we need to provide UV light. Question 22. Phenylamine can be converted to 4-nitrophenol by the following steps. So, phenylamine in step 1 forms a compound that is converted into phenol, which is converted into 4-nitrophenol. So, the only compound that can be made from phenylamine to be converted into a phenol is benzene diazonium chloride. So, we have N triple bond N positive and Cl negative attached to the benzene molecule, which is compound B. So suggest the identity of the intermediate B by drawing the structure in the box above. Already done. Suggest reagents and conditions for the three steps in the above scheme. So step 1 requires HNO2 plus NaNO2 plus HCl plus temperature less than 10 degrees Celsius. So we can actually include the temperature being less than 10 degrees Celsius as the condition. So let's rearrange the reagents HCl here and temperature less than 10 degrees Celsius over here. Next we have step 2, in which the benzene diazonium chloride is converted into phenol. So we need water and we need to heat benzene diazonium chloride with water to produce phenol, and the temperature here should be greater than 10 degrees Celsius in order to form phenol. And in step 3, we have phenol being converted to nitro for nitrophenol. So for that we need HNO3 along with H2SO4. No, this is phenol. We don't need H2SO4 here. The only thing we need is HNO3, and this reaction can be brought at room temperature. So the acid can be dilute and the conditions have to be room temperature and pressure. So this will convert phenol into 4-nitrophenol. Question 23. The analgesic drug paracetamol can be synthesized from phenol by the following route. Suggest reagents and conditions for each of three steps and suggest the structure of the intermediate H. Write your answers in the boxes provided. So the entire organic synthesis pathway is given, and we'll have to work our way back from the structure of paracetamol to find out what is going on. So, in step 3, we have conversion of the amine group into an amide group. That means the reaction would be with an acyl chloride. So, the reaction would be with CH3 COCl. And before we have the amine group, an intermediate H forms. The intermediate H would be something that contains a nitrogen atom because originally phenol did not have a nitrogen atom. And the conversion from the nitrogen containing group to NH2 is the conversion of nitro group to amine. So this would be 4-nitrophenol, which would be compound H. Now, in order to convert nitro group into the amine group, the conditions and the reagents required are 10 plus concentrated HCl. And in step 1, conversion from phenol to nitrophenol would require HNO3 aqueous only. And if conditions need to be mentioned, then we can mention RTP. So this completes the organic synthesis pathway going from phenol to paracetamol. Just in order to be a little more specific, the HNO3 used in step 1 must be dilute. Question 24. Phenol can be synthesized from benzene by the following route. So benzene on reaction with HNO3 and H2SO4 would produce nitrobenzene. The position of the nitro group is decided on the basis of the position of the NH2 group, which is the product of step 2, and the nitro group is reduced to the NH2 group, which on reaction with NaNO2 and HCl and a temperature of less than 10 degrees Celsius would result in the formation of benzene diazonium chloride. And benzene diazonium chloride upon hydrolysis at temperature greater than 10 degrees Celsius would result in the formation of phenol. Suggest structure for compound D and E and draw them in the boxes above. Done. Suggest reagents and conditions for step 2. So the reagent and condition for step 2 is tin plus concentrated HCl, and the reagents and conditions for step 4 are water plus temperature greater than 10 degrees Celsius, or we can write warm or heat, which would suffice. The following chart shows some reactions of compound F, which is a neutral compound. G forms a salt with dilute H2SO4. That means G is alkaline, whereas H forms a salt with NaOH. That means H is acidic. Both G and H can be obtained from compound J by separate one-step reactions. Reaction 1 and reaction 2 below. All four compounds F, G, H, and J form a yellow precipitate with alkaline aqueous iodine. So all of them have a methyl ketone or a secondary alcohol group present in them next to a CH3R group. So compound J contains one nitrogen atom, it contains four carbon atoms, and it contains one oxygen atom, and it's supposed to be a methyl ketone. So CH3 C double bond O. This much of the structure is complete. Now what are we left with? We are left with two carbon atoms. So we can have a CH2 group. So all five hydrogen atoms have been used up. So we are left with one carbon and one nitrogen, resulting in the fourth position being occupied by a nitrile group. So this is structure J. And this makes sense because a nitrile can be oxidized into a carboxylic acid and it can be reduced into an amine. So H is CH3 C double bond O CH2 C double OH, which is acidic, And G is CH3C double bond O. In fact, if it is being reduced, then C double bond O also undergoes reduction and it is reduced to a secondary alcohol. So this will be OH and this C will have a hydrogen attached to it. We have a CH2, we have an additional CH2 from CN and the N becomes NH2, making this an alkaline compound amine. So structure F is heated with dilute acid. That means it undergoes acid hydrolysis. And since our products contain a carboxyl group and an amine group, it means that a CONH, amide bond, must be present in this compound. So we have a C double bond O group from structure H and an NH group from structure G. And we complete the structures. On the left side, we have got two CH2 groups, CH2, CH2, then we've got a CHOH and it ends on a terminal CH3 group on the left. On the right side of the C double bond O group, we have got a CH2, a C double bond O group, a ketone group, and we have a terminal CH3 group on the right side as well. So this is the structure of compound F. Now, just to make sure, compound F contains a methyl ketone group or a methyl group on a secondary alcohol. Compound G contains a methyl group on a secondary alcohol, and compound H contains a methyl ketone group. And compound J already had a methyl ketone group. So the structures drawn F, G, H, and J are all correct. Suggest reactants and conditions for reaction 1. Reaction 1 is reduction, so this requires LiAlH4 plus dry ether. And reaction 2 is acid hydrolysis, so this requires HCl aqueous plus water plus heat or heat under reflux. So these are the conditions for reactions 1 and 2.